Exploration 3 has the same directions as Exploration 2. Graph and label each line in the coordinate plane, and if the equation is not in slope-intercept form, first convert it. So as we look at line A here, I do notice this is not in slope-intercept form. This is in standard form, so we need to solve for y. All right, so first step here, we're going to create a zero term out of the x. X minus x is a zero term. That leaves us with a positive 4y equals a negative x, because we had to subtract it, minus 20. All right, now we're going to divide all terms by 4. Because 4 divided by 4 gives us a big 1. And y is now by itself. And to simplify the right side, we just have to simplify all of these quotients. What is negative x divided by 4? That wouldn't be negative 4x, because that would be negative 4x divided by 1, and that's the reciprocal. So what is negative x divided by 4? Well, if we recall, anytime you have a variable like a negative x, that's equivalent to a negative 1x. There's a hidden negative 1 in front of that variable. So if I put in that hidden negative 1, now I can clearly see that this is the fraction negative 1 divided by 4, or negative 1/4. All right, that was kind of a tough one. Let's see, negative 20 divided by 4, that's just a negative or a minus 5. Okay, so now that it's in slope-intercept form, we can clearly identify the slope as negative 1/4, and my y-intercept when I plug in 0 for x is at 0, negative 5. So here we go. Let's go ahead and graph. Starting at 0, negative 5, my slope here is negative. So that means I'm going to be going down and to the right. So down 1, to the right 4. There's another point. Down 1 to the right 4, another point. And I've run out of room. So going back to 0, negative 5, I'm going to go up 1 and left 4 until I run out of room. And graph these in a line. I'm going to put arrows on either side and label this as line A. All right, that wasn't too bad. Line B, we're not given an equation for line B. Let's see what we are given. Graph and label a line B that is parallel to line A and contains the point 8, negative 3. So if we're given this information, what can we conclude? Well, since we know that parallel lines have the same slope, and we definitely know the slope of line A. The slope of line A, we found that to be negative 1/4. That means the slope of line B is also negative 1/4. All right, so at least we know the slope of the line. But this is not the y-intercept of the line. So let's put this into a different form. If we're given a point on the line and the slope of the line, we can use what's called point-slope form. Y minus y1 equals m times x minus x1. This is why this form exists. Okay, so let's fill in what we know. Our point here is x1, y1, and our slope is m, negative 1/4. So y minus the y-coordinate, y1 is negative 3, equals our slope, negative 1/4, times x minus 8. All right, so now that it's at least in an equation, we can go in here and convert. So the first thing I'm going to do is I'm going to change this subtracting a negative into adding a positive. So that would make this y plus 3 equals, and now I'm also going to distribute on this side. So negative 1/4 times x is negative 1/4 x. And a negative 1/4 times a negative 8 will definitely be a positive. And 1/4 of 8, negative 1/4 times negative 8, 8 divided by 4 is, that would be negative 2. So that's plus 2. Okay. Now subtract 3 from both sides to make that 0 term on the left. And we have y equals negative 1/4 x minus 1. Cool. So now we have the y-intercept, and we have a point on the line to see if our work was actually correct. So our equation here, negative 1/4 x minus 1. Okay, so starting at 0, negative 1, we're going to use, again, our slope is down and to the right. It should be parallel. If I were to go up and to the right, it definitely wouldn't be parallel. Down 1, right 4. Down 1, right 4, ran out of room, go back to 0, negative 1, up 1, and left 4. up 1 and left 4. And let's connect these in a line. Put some arrows on that line, and we'll go ahead and label this line B. So use geometric notation to show if any lines are parallel. Do we have parallel lines here? Well, yeah, we definitely have parallel lines because we created line B so that it was parallel to line A. So let's go in and put our notation to show that these two lines are parallel. So let's see. This time around, I'm going to go ahead and put 3 arrows on line A. We're going to go crazy here. So if I put 3 arrows all going the same direction on line A, then that means I have to put 3 arrows all going the same direction on line B. And if we wanted to cap it off, we could use our geometric notation to show that line A is parallel to line B. All right, that wasn't so bad. Let's see what we have to do next. Graph and label a transversal T that is perpendicular to lines A and B. Wait a minute, perpendicular? That doesn't mean that we can just choose any old slope we want. What do we know about perpendicular slopes? That's right, perpendicular slopes are opposite reciprocals. Opposite meaning if it's positive, it becomes negative, negative becomes positive, and reciprocal means that the numerator becomes denominator, denominator becomes numerator. So the slope of A and B is -1/4. That's the slope of line A and B. So we're going to change that from a negative to a positive, and we're going to use the reciprocal, which would be 4/1. So now we know that our transversal to be perpendicular must have a slope of 4/1. So the equation, if we wanted to get it started, will look something like this, 4x. And we just need to pick ourselves a y-intercept. I'm going to go ahead and use 3. So we will start our graph at +3, and there's the equation of our transversal. All right, let's graph this. So starting at 0, 3, my slope is 4/1, meaning I'm going up 4, 1, 2, 3, 4, and to the right 1. And can't keep going, so now we're going to go down 4, 1, 2, 3, 4, and to the left 1, definitely intersecting point or line B. 2, 3, 4 to the left 1, and definitely intersecting line A. Graph those in a line and label this transversal T. All right, one way to tell that you actually do have perpendicular lines is if you're home or something, you can grab any piece of paper, ID card, something that has a right angle in the corner, and then you can grab that over and put it into that angle and see, does that match up? And yes, it does. So all papers, squares, rectangles have right angles in each corner. So as I'm moving this around, it does actually look like transversal T is perpendicular to A and B. We actually have geometric notation to show perpendicular as well. If we wanted to show that transversal T was perpendicular to, let's say, line A, we would draw a mini perpendicular line, a vertical and a horizontal, and that symbol means perpendicular. Line T is perpendicular to line A. Well, line T is also perpendicular to line B, so we can say that line T is perpendicular to line B. So that's just how we would represent that using geometric notation. Great, so almost done here. What's left is to label the interior and exterior angles. So again, if you remember, our parallel lines form this river, and anything inside the river is an interior angle. Anything on the river bank is an exterior angle. So let's go ahead and label those now. Okay, so I went ahead and labeled 1, 3, 5, and 7 in the interior, 2, 4, 6, and 8 in the exterior. And by the way, it didn't necessarily have to be here. 2, 4, 6, and 8 could have been any of the exterior angles. So put 2 up here, 4 down here. It doesn't really matter as long as you're clearly indicating which are inside the 2 parallel lines and which are on the outside. And that concludes exploration 3.